Hello students, today we are going to discuss about the inverter. What is an inverter? Inverter is going to convert a DC source into AC. Okay. So there are two types of inverters are there. One is single phase, another one is three phase. Depending upon the phase, there are two types, single phase and three phase. In single phase, we are having four switches. Okay, these are the four switches. Whereas in three phase we are going to have 6 switches. Okay, depending upon which phase we required, we are going to use accordingly. Now what are the different types? Basically there are two types are there. One is bipolar, another one is unipolar. In bipolar we are going to get two poles, that is plus VDC and minus VDC. Okay, so comparing to the here, if you observe, so here the positive voltage is more positive than the negative one, and here after a half cycle negative voltage is more than the positive one. So like this, if you are going to see at the end, the resultant will be a sinusoidal one. Okay, it is not exactly the sinusoidal, but it resembles a AC. In unipolar we will be getting either plus VDC or minus VDC. Okay, only one pole at a time we can able to get. That is the reason why we are going to call it as a unipolar. Okay. Now sinusoidal pulse width modulation. What is the requirement of pulse width modulation? Generally, if you take in a single pulse, we are going to get lot of harmonics in it. So in order to reduce those harmonics, we are going to use a pulse width modulation technique. Okay, so in that one we are going to discuss now today sinusoidal pulse width modulation. Okay, so in sinusoidal pulse width modulation we are going to take a sinusoidal signal and a repeating sequence. Okay, generally we call this sinusoidal signal as a modulating signal and repeating signal as a carrier signal. Okay, so here by using the modulating signal we are going to fix the fundamental frequency. What is fundamental frequency? Suppose our grid frequency is 50 Hz. If I want to construct or develop a inverter for 50 Hz, then I am going to maintain a modulating signal of 50 Hz. Okay, and in case if I want to change the frequency, then you can able to change the modulating signal frequency, okay, to any frequency, either 35, 25, 60 Hz. Then you have to change the modulating signal frequency. Okay, next coming to the output voltage. Sir, can I get a variable output voltage? Yes, you can able to get a variable output voltage, but the thing is you have to change the magnitude. Okay, you have to change the magnitude of the modulating signal. The modulating signal magnitude you have to change. Okay, if you can able to change this magnitude, then accordingly the output voltage is going to change. Okay, maximum value we can able to maintain here is 1. Okay, generally. So if we are going to reduce less than 1, then your output voltage will be reduced accordingly. Okay, now coming to the frequency. So if your frequency is high, then your number of pulses are going to be increased, and you can able to reduce more number of harmonics. So how many harmonics I can able to reduce, sir? Say suppose your switching frequency is 5 kHz and your fundamental frequency is 50. Then 5 kHz by 50, that is nothing but 100. So you can able to reduce 100 harmonics. 100 harmonics we cannot reduce to 0. There will be a little harmonics will be still, there will be effect will be there. Okay, so by this method, so we cannot reduce completely, we cannot eliminate completely all the 100 harmonics. Okay, so what about the 101 harmonics or more than the 100 harmonics? That we can able to use a filter. Okay, we can use a filter. We can able to keep a cutoff frequency of the 5 kilohertz. Okay, so like that we can and the filter size will be very less because it has to attenuate a high frequency. So obviously the area will be the size of the filter will be very small. And why can't we able to apply the same filters here instead of using pulse width modulation? Because we need more number of filter, and filter size will be very high. Say suppose third harmonic is that is 150th 150th frequency will be there. So but size of the filter is going to be increased, and at a time a filter can reduce hardly one frequency. Okay, so that's why we are going for this pulse width modulation. Next, coming to the unipolar. What is the basic difference between bipolar and unipolar? In bipolar, we are going to use only one modulating signal. However, in unipolar, if you come to the unipolar, so here we are going to use a complementary sine signal. Okay, another one complementary sine signal. This is one signal and this is another signal. Here, if you take in the inverter, we call these two switches as when these two are conducting, then power will flow like this. When these two are conducting, then power will flow in the negative direction. So we call these two as positive switches. This Q1 and Q2 as positive, Q3 and Q4 as negative. So if you take this one, so here this signal, it is going to turn on the positive switches, and whereas the negative control signal, it is going to turn on the negative switches. Okay, like this we can able to generate a unipolar like this we can able to apply unipolar method. Okay, sinusoidal pulse width modulation. So in this video we have discussed about the theory. However, in the next video we are going to discuss about the practical part, that is we are going to simulate this in the MATLAB. Okay.